Dear students, already we have discussed one method, that is Newton-Raphson method, which helps us to solve the equations in numerical methods. Today we will discuss another method, that is secant method. The name itself says why it is called secant method. So secant, you see, whenever we consider a curve and on that curve we consider 2 points, then the line joining that 2 points is called a secant. Now let us prove the formula for this secant method. So you consider the axis, that is x-axis and y-axis, and consider a curve like this. Okay, so y is equal to fx is curve. Say on this curve A is a point with coordinate x0 fx0 and B is a point with coordinate x1 fx1, right? So we consider A with coordinate x0 fx0 and B with a point x1 fx1 are 2 points on curve. Then we join these 2 points. If we join these 2 points, now this line is the secant. Then equation of AB in 2.4, that is y minus fx1 by x minus x1 is equal to fx1 minus fx0 by x1 minus x0. So this represents the equation of this line. Now you see, from the geometrical point of view, this point is the approximate solution and this point is the exact solution. Say this is xn or xi is the exact solutions and this one is the approximate solutions. As we have considered x0 and x1, by that we are getting this line, so you call this point as x2. That means x2 is the first approximate solutions, right? So when we will get x2, at that point what is the value of y? Because this line cuts x-axis at this point, so the value of y is 0. That is why put y equal to 0 in these equations. Put y is equal to 0 in it. Then what happens? If we put y equal to 0, that gives minus fx1 by x minus x1 is equal to fx1 minus fx0 by x1 minus x0. If we simplify it, we can get x minus x1 is equal to minus x1 minus x0 by fx1 minus fx0, right? Means we keep this x minus x1 in the right hand side and this expression comes to left hand sides. Okay, so this gives, after simplification, it gives like this. So that implies x is equal to x1 minus x1 minus x0 by fx1 minus fx0 into fx1. So this is the formula which says if we know the two initial values x0 and x1 and from that we get the secant line and that line gives a new solution x, means we are using x0 and x1 in this formula, this is our input data. By using x0, x1, we get a data x, and that x will be called as the iteration value x2, because already we have used the notation x0, x1. So this new value we will call as the data as x2. Now we get the formula as x is equal to x1 minus x0 by fx1 minus f of x0 into f of x1. You see here we consider the initial values x0 and x1, from that we get a new value x. So for the time being we will call this new x as x2. So we get x2 is equal to x1 minus x1 minus x0 by fx1 minus fx0 into f of x1. So this is the formula for the second method. So if using x0, x1 we get x2, similarly we can find x3 is equal to x2 minus x1 by f of x2 minus f of x1 into f of x2. Proceeding in similar way for n steps, we get x n plus 1 is equal to xn minus xn minus xn minus 1 by f of xn minus f of xn minus 1 into f of xn. So this is our formula which finally we derived, and we will use this formula to find the solution of equation using second method. So this one is called as formula for second method. This is all about the derivation. In the entire derivations, you have to remember two things. We consider the initial values x0 and x1. From that we get x2, and from x2 again we will get x3 and so on. You see how we get it. If this is x2, so here we can draw a perpendicular. So we can join these 2 points. This will give the x3. Again we can draw a perpendicular. We can join this point will give x4 and so on. So this process of iteration leads us to arrive at the exact solutions xn. So that is the idea that how we derived the second method. After deriving the formula for second method, now we will consider a numericals, and we will see that how we use the second method to solve the equations, and that is the beauty of the problem. In every problem we have to solve some numericals to know the clear idea about that problem. So we consider one example. Say solve e to the power minus x is equal to 0 by second method. Okay, so we'll start the solution. So here you just remember in the formula we use the function. So for this question we will consider f of x is equal to e to the power minus x. This is the functions, and we have to decide two initial values, because in the formula we have started from two initial values, one is x0 and other is x1. So how we will start, or how we will get the two initial values? Just by trial and error, you test f of 0. If we put f of 0, that is e to the power 0 minus 0, that is 1. F of 1, that is e to the power minus 1. So that equal to minus 0.632121. Once we found these values, we will observe whether these two values are close to 0 or not. Okay, this one is close to 0, that may be positive, negative, no matter, but it should be close to 0, and this one also we may consider this is nearly equal to 0. So from these discussions we conclude that we can consider this 0 and 1 are the two initial approximate solutions. And remember, here we are not giving importance to the positive negative nature of the functions, what already we have discussed in some other methods like bisection or regular fallacy or Newton-Raphson, where we have used the opposite signature. The advantage of this formula is arbitrarily we consider 2.60x1 and we observe the value of functions is close to 0. Okay, no need to test the positive negative nature. Okay, so using this, now we will calculate the new approximate value from this x0 and x1. So we will start the step 1. In step 1, x0, because we have to consider two initial values, we consider x0, the first initial value x0 is equal to 0 and f of x0 is equal to f of 0, that is 1, and second initial value x1, that is 1, and f of x1, that is f of 1, is equal to minus 0.632121. Then using these two, we have to get the new solutions, that is x2. So as per the Newton-Raphson formula, x2 is equal to x1 minus x0 by fx1 minus fx0 into fx1. Just you put the values, that equal to x1 is 1 minus 1 minus 0 by f of x1 is minus 0.632121 minus f of x0 is 1 whole into f of, this is our x1, f of x1 is minus 0.632121. So if we simplify this, we will get the values, that is x2 is 0.61270. Okay, so by this is the formula of second method. By applying the second method with two initial values, we get x2 is this. Now here we have to add one more thing, that whenever in every steps we are finding the approximate solutions, we have to test in that solution what is the error. The error formula is epsilon 2, that is error is epsilon 2. Why we call epsilon 2? Because this is the value x2. In this value, the value approximate value x2, we call the error as epsilon 2. The formula is x2 minus its previous value x1 by x2 modulus into 100. We know the value of x2, we know the value of x1. All these two values we will put here and we will multiply. After this, we will get epsilon as 63.22%. What it says, if we consider x0 as initial value, x1 as the second initial value, from that we get x2, and this is the result x2, and in this answer the error percentage is 63%. So are we satisfied to get a solution which bears 63%? Definitely not. So we have to proceed further. As in the approximation value x2, we found that the error is 62%, so we are not satisfied. So then we try to find the next approximation x3. So that is the step 2 or the second iteration. To find x3, right? For x3, what the value we require? For x3 we require x1 and x2. So what is x1? x1 is 1 and x2 is 0.61270. If x1 is this, what is f of x1? That is f of 1, that is minus 0.632121, and x2 is this, so f of x2, that is f of x2 is f of 0.61270, that equal to minus 0.070814. Okay, so once we know x1 and x2, we have to calculate x3. So the formula is x3 is equal to x2 minus x1 by fx2 minus fx1 into fx2. Just you put the values, that equal to x2 is 0.61270 minus x2 is 0.61270 minus x1 is 1 by f of x2, that is minus 0.070814 minus f of 1, that is minus 0.632121 into this is x2, so you have to calculate f of x2, that is minus 0.070814. If you simplify by using the calculator, you will get the result as 0.56384. Okay, once you get this x3, then you have to calculate the error epsilon 3, that is x3 minus x2 by x3 modulus into 100. This part is the relative error, into 100 gives the percentage error, that gives x3 in this value and x2 is this value. That is, if you calculate, the error is 8.67%. You just recall, in the previous case when we have found out the solution x2, there we are getting 62% error, but here we are getting 8.67. That means in the iteration value x3, gradually the error is decreased. Next, in step 2, we have calculated the value of x3 and we found the error, that is 8.67, and 8.67 is not a small error. That is why we will go for the next iteration, that is x4, and we have to calculate in step 3, that is what is x4. For x4 we need x3, x2, f of x3 and f of x2. So what is x3? In the previous step we have calculated x3, that is 0.56384, and f of x3 is equal to f of 0.53384. The result is 0.00510. Also in the previous steps we have calculated x2 and f of x2. x2 is 0.61270 and f of x2, that is f of 0.61270. The result is minus 0.070814. 0814. Once we know the value of x2 and x3, we will use these two values x2, x3 and f of x2, f of x3 in the second method to get x4. What is x4? x4 is equal to x3 minus x2 by f of x3 minus f of x2 into f of x3. That equal to x3 is 0.56384 minus again x3, that is 0.56384 minus x2 is 0.61270 divided by f of x3. F of x3 is 0.00510 minus f of x2, that is minus 0.070814 into f of x3. F of x3 is 0.00510. Then using calculator you simplify and you will get the value x4, that is 0.56712. So this is the value of x4, right? And once we get the value of x4, we have to decide whether this approximate solution x4 will be our the desired result or not. For that, we have to calculate the error epsilon 4. Epsilon 4 is x4 minus x3 by x4 mod into 100. That is x4 we have calculated, that is 0.56712 minus x3 is 0.56384 divided by 0.56712 modulus into 100. So the result is 0.58%. Now you see, in these steps, when we consider or we calculate the value x4 as 0.56712 by the second method, we get the error for this value is 0.58%. As the error is 0.58% means this error is less than 1%. So we can conclude that this x4, so x4 is equal to 0.56712 is a good approximate result because the error is less than 1%. Like this we will solve all the problems in second method for successive steps x1, x2, x3, x4 and so on, and in every step we have to calculate the percentage error. When the percentage error will be less than 1, at that step we will stop the process and that final result will be our solutions. Okay, thank you.